Tenakwe again, everyone. We're moving straight on into the next video. Here is what our game looks like so far. I'm just going to zoom this code out a little bit for you so that you can see what we have. Hopefully you can still read that with the resolution of YouTube. So we currently have a player getting onto the screen. We have a single crate on the screen, and we have the physics engine working as well. Here is all of our logic for moving the player with the keyboard. Here is all of our logic for drawing, updating, setting everything up, getting the actual window class working as well. Okay, a couple of things to do. First of all, let's add in box scaling as a constant. Let's set that to 0.5. And like I said last video, very important that this is a power of 2. So they're 128 wide normally, but now they're going to be 64 wide as well. Not as well, instead. And I'm just changing in where we are generating that wall. I'm changing it to box scaling. Okay, here's what we're going to do. We're going to get some more boxes onto the screen in a couple of different ways. So we are going, let's just zoom in here in our setup area. Okay, we've created our wall list as a arcade.sprite list. It's currently empty. Let's add some more boxes into it. Let's go. Okay, wall is going to, let's get 10 boxes up. So let's go, we're doing something repeated, we need a loop. In particular, we need a for loop. So for I in range 10, so we can do something 10 times. We're going to go, wall is going to equal that. That's all fine. It's center X is going to be, what is it center X going to be? It's going to be I times 64, isn't it? What is its Y going to be? It's, let's make it close to the bottom, so let's make its center Y. So if it's going to be just a strip along the bottom, we want to lift it half the height of the box off that bottom, off the bottom edge of the screen. Half of 64. 32, thinking today. So center Y is always just going to be at 32, and we're just going to create a nice flat row of boxes along the bottom. And right. We also need to offset that first block by 32 pixels. I'll show you why. When we run it, this is going to happen. That's cool. That's nice. Starting to look like a floor. See this box, though? I don't like it. I don't like it. It's cut in half. So we need to offset it by that. That's actually surprisingly hard to do. It would need to offset it by half of a crate. And we already know what half of a crate is. We need to go from there to there. Half of a crate is 32 pixels. We need to add 32 pixels to each of the crates' location. How do we do that? Inside here, we just say plus 32. And do we need to worry about putting brackets on? No. It's programming. They follow BEDMAS. It's fine. They're going to evaluate that first and then add 32 onto it. All good. Hey, better. Nice. Starting to feel like we should have a few more boxes on that other side. Let's, rather than doing it 10 times, 13? Close. Close enough. Okay. It's carrying on. And it cuts off on the other side because our width isn't a power of 2 at the moment. But that might be something to think about. Okay, cool. You can also add boxes in just by their location, of course. You could click the mouse and have a box appear there. I don't know why you would do that in the game, but maybe you're thinking about creating a level and you just kind of want you just kind of want to be able to design it sort of hack, and you just want to click and have a box appear. You could do it that way. That's a challenge to you. Or you can actually do this as a list as well. You can make a list of X and Y locations and have and actually use a for loop to go through that list and spawn the boxes there. Should we do that? Of course, let's do it. Let's make a few let's make that list. And let's say this is box coords. And we're going to set this to be a list. Each of these is going to be a little list themselves, and we're just going to hard code these in. What are we going to say here? Let's say 400, 500. Cool, that's one. This is now an array of depth 2, because it's an array in an array. Lists in lists. What we call a matrix. How awesome. 470, and I'm pulling these straight off the reference, by the way, guys, so you can go there and check it out. 400. Oops, I've missed a square bracket. Thar. 400, 570, and last one is going to be 470, 570. That's not what I said. I said 470, 570. Okay. We've got a list of coordinates, and you can change this to whatever you want. It can be completely arbitrary. You'll notice as well, these numbers are not a power of 2 apart. Ooh, what do you think that's going to cause? Okay, let's get them into our sprite list. Let's say for coordinate, for coord in box coords, and we're gonna pretty much grab this same as, and we're gonna say instead of being at X, we're gonna be at coord 0. The first time this for loop goes around, coord becomes this array, the first thing in the outer array, and then we're pulling out the number 400 by indexing it with those square brackets. All right, a nice little bit of array practice. Coord 1. And then we're adding that box to our wall list. Let's go. Always check down the nav bar, see if it's actually working. Man, that's a strange mistake. In, not equals. Cool. Hey, look at this. I've got a character. She can move around. She can stand on boxes. She can move up here. I suspect... no, she can't actually fit through there because the physics engine is preventing her from moving through there. She can't actually fit through that gap either because she's too wide. And that's it. We've got extra walls happening. We've got this cool other little pattern up there. So notice how because this... Oh, I've set mouse to invisible. Because the ones up there aren't a power of 2 apart, they're 70 pixels instead of 64 pixels apart, we end up with that little sliver. Whereas down here, they are an exact multiple of 2, and we've made sure, multiple of 2, power of 2, and we've made sure that our sprites, our actual images for these, are a power of 2 as well. They tile so nicely, repetitively, all the way down there. All right, that's it for this video. Ka kite anō.